1, lesson 78, rational equations. A topic you already know more about than you probably imagined. Let's look at an example. These problems can be quite cute. I think we've done something like this. We'll see if you remember. Y over 2 plus 1 over 4 equals y over 6. Now, when we have expressions do not have equal signs. When we have expressions, we cannot hope to eliminate our denominators. We're stuck with them, that's just the way it is. But when we have equations, which again, we know we have when we have an equal sign, we can blow up the denominators. We can make them go completely away and come up with an answer that is just a nice, cute number. Sometimes it'll end up being a fraction, but we can make them go away. And here's how we do it. The first thing we do is find the least common multiple. Well, that's something we've done a bazillion times. We know how to do that. We're looking for the smallest number 2, 4, and 6 will fit into. Well, we know 2 fits into 4, so we don't have to worry about 2 anymore. 4 does not fit into 6. Would have been nice if that was an 8. So we have to find a number that both 4 and 6 will fit into. 4 times 6 is 24, but we don't have to go that high, do we? We can find 12. 12 will work. The second step, and this is where it seems a little weird, is we multiply all the terms in the whole equation by that LCM. Okay? So what I'm going to do is I'm going to write it again just so that we can see this more clearly. We're going to multiply this by 12, and this by 12, and this by 12. I'm going to put parentheses around them now so you'll remember that we're multiplying. Later I won't do that. I won't take the time to do that. I'll just write the number up there and you'll know. This is me multiplying each of these numbers by 12 over 1. Now what happens when we do that is the 12 and the 2 will cancel against each other. So what I do is I go like this, and then I write 6 times. 12 and 4 cancel to 3. 3 times 1. And then 12 and 6 cancel to 2. So 2 times y. And then for our final, and so you see all of our denominators eliminate. That will always happen because we set up our least common multiple so that they would all fit into that number and cancel out. And so now our denominators are gone, and all we're left with is 6y plus 3 times 1 is 3. Oh, this should be an equal sign, sorry. Equals 2y. Let's subtract the 2y from both sides, and let's subtract the 3. And we get 4y equals minus 3, and then we divide by 4. So we did end up getting a fraction as our final number, but we were able to completely eliminate fractions from our calculation, which makes the math a lot easier. We end up with a fraction in the end, but we don't have to do anything with it in this particular problem. So that's how we can get rid of denominators, or as I like to say, we can blow them up in equations. This, again, it does not work for expressions that have no equal sign. This only works when we have the equal sign. Let's try another one. Example 78.2. 2x over 7 okay. 2x over 7 minus 3x over 2 equals 1/3. Alright, so we find our least common multiple. And these are all prime numbers. Prime numbers and knowing how to combine them is super helpful in finding your LCMs. These are all 3 primes, so none of them are going to fit into each other. So the way we get our LCM is to multiply them all together. 7 times 6 is 42. So then I'm going to multiply each term by 42. I I just have developed the habit of writing it up here like that. It's 42 over 1, so we're canceling against our denominators. So this becomes 6 times. Now this multiplication is going to be a little messier. 42 times divided by 2, that's 21. And then this is 14. Alright, so now we have 12x minus 63x equals 14 times 1 is 14. Make sense? Now let's see, we can combine like terms here. This would be minus 51x equals 14. Oh, that's a really weird answer, isn't it? So we get x equals minus 14 over 51. Final answer, yay, that's right. This was right also. Okay, getting the hang of this. Let's make it a weensy bit harder. There are 2 more examples to work on this kind of problem. And they are just a little more complicated, not necessarily hard. Example 78.3. 3y over 2 plus and this is just a plain 3, but I'm going to put it over a 1. Okay. We have an expression here instead of just a simple multiplication. Oh, Gracie's come to say hi. So that's going to make it a little easier. I want to put this in parentheses right away so I don't get confused when I'm doing my multiplying up here. But we need to find our LCM. 2 and 7 are both prime, so we have to multiply them together to get 14, and we're going to multiply everybody by 14. He's going to cancel to get 7. He's going to cancel to get 2. Okay, so this 2 we're going to have to distribute across that. And then this isn't going to cancel at all, so this is going to be 14 times 3. All right? So let's revamp. 21y, and here's how we'll do that. Plus 16 minus 8y equals 42. Combining like terms, and then let's swim the 16. 21 minus 8 is going to be 13y. That cancels. And then this is going to be 26. Oh, John, look what you did for us. Y equals 2. And that's correct. Okay, so what happened in this one that was harder is we had a subtraction in a term, so we have to put parentheses around and then distribute. Okay, and then our last one, we have 2 that are like that. 2 of the terms are like that. 78.4. Here we go. Plus 1 over 4. Okay, and so here we have 2 numerators that are binomials, and so we parenthesize, just verbed that, we parenthesize those so that we don't screw up the multiplication. 2, 4, and 10. What can they all go into? Least common multiple. Okay, 4 is 2 times 2. I'm writing down the prime factors underneath them. This is 5 times 2. So I know that I'm going to need to have at least 2 2's and a 5. So it's 2 times 2 times 5. That will give us our least common multiple, and that is 20. Okay? So using your prime factors and gathering up a full set of them will get you your answer. I'm now going to squiggle this out so I don't confuse myself. 20 is my least common multiple. Alright, and now I'm going to cancel. 20 into 4 into 20 is 5. I'll have to distribute there. 20 and 2, that's 10. That one's going to be fine, it's just a multiplication. 20 and 10 is 2, and again, that will be a distribution. All right? So now I'm going to distribute 5x plus 5 minus 30 equals 4x minus 18. That's after the distribution. All right. Like terms, this is what, minus 25. Let's subtract the 4x, and let's add the 25. X, that all cancels, equals, that all cancels, and that is 7. And that's our final answer. Okay? So, moral of the story, when you have a binomial expression in your numerator, put parentheses around it so that you can distribute after you do the dividing. All right, that is lesson 78. Good luck. I'll see you in 79.